Welcome to the Oldcastle Inventor video series, creating a concrete half box. Let's begin by going to New. If you haven't already set your project to the current project, please hit pause on this video and do so now. After setting your project, let's choose Concrete Part. And before we start modeling, we're going to enter some basic parameters here that we can reference later in our structure. So I'm going to hit Add Numeric and type in height. If you tab over, it usually enters the information and allows you to go on to adding your next parameter. So I'm going to repeat that operation, add numeric. I'm going to type in width, tab over, add numeric, type in length, tab over, type in wall, tab over, and floor, tab over. Now I'm going to enter some generic dimensions here, but please feel free to enter the ones that you need to add for your given structure. My height is going to be 48 inches. My width is going to be 60 inches. My length is going to be 60 inches. My wall is going to be 6 inches. And my floor is going to be 7. Once you get those values entered, go ahead and hit done. And I like to use the box command. That's how I'm going to start, because I like to minimize the amount of functions that I need to use in order to get the same result. And I believe 2015 was the first edition of Inventor that allowed you to create a three-dimensional box with a selection of one command. So go ahead and select box and select your plane that you want to put your first sketch on. Once you're in sketch mode, let's go ahead and choose the center of our box. Just like AutoCAD is asking us with a prompt, either in front of us near your cursor or on the bottom left-hand side of the screen, to choose your operation. So after I select my center point, I'm going to drag my cursor into the upper left quadrant, and notice how the dimension on that horizontal line at the top is highlighted. This means that it's prompting us to enter that information. So in order to get my OD of my structure, that's important to note here, I'm going to type in length plus 2 times the wall. And as you notice, it went from red to black. What that indicates is that this field here that we're entering information in is able to quickly notice that we are trying to reuse parameters that we have entered into our table for the use of modeling. So once you enter that, it should turn, like I said, it should turn black. Go ahead and hit the tab button to reduce the time spent clicking, and it should automatically put you into edit mode for that vertical dimension on the left there. If you see it highlighted in blue, we're going to basically do the same thing. We're going to type in width plus 2 times our wall, changes from red to black, and let's go ahead and hit enter. When you hit enter, it is automatically going to try to make this 2D sketch into a 3D object. We need one more dimension, and it's going to prompt us with an extrude command here automatically, which is a nice little function of the box command. And we're going to go ahead and type in height plus the floor. And that is going to, like I said, give us our overall height of the structure. Our arrow is going to be pointing by default in the vertical positive direction of our z-axis here if we selected the XY plane. Not that this is necessarily important, but it does allow for consistency among all of my parts. So I try to build mine on the same planes from scratch. Go ahead and hit OK, and we'll see our nice three-dimensional box here. We need to do a couple of more things. We basically need to core this object out, and in doing so, we're going to hit right-click and go to New Sketch. We're going to select the topmost surface of our box here on the upper part of the z-axis. And once we do that, it automatically creates our sketch there. And one thing that I wanted to point out here that I didn't notice for my own sketch is that normally I like to project these outer lines in. Any outer line that is touching the sketch, I like to have automatically projected in so that I can use as a reference. We can toggle this option on in our application options. So there are a couple ways to get there. You can go to File or in Options, or you can go to your Tools tab and go to Application Options. It will take you to the same menu. Find the Sketch tab, and down just below the middle you'll see this Auto Project Edges for sketch creation and edit. Go ahead and just turn that on for future's sake. It's not going to project the edges in just because we toggled that on now, but for any future sketch that we create on a three-dimensional surface, it will pull in those dimensions for us. Well, we can check if we want to. We can go ahead and finish our sketch and delete it. I'm just going to left-click on the sketch 2, right-click and delete. And I'm going to basically repeat the operation. New sketch, place it on the top, and there we have it. Our outer edges have been projected in, and I'm allowed to use them for reference. So what we're going to do is core this thing out. Like I said, we're going to go to our Sketch tab, and somewhere up here there is Offset. Let's find that. You can also hit O on your keyboard. That should be by default the quick key. Select our outer boundary, and we'll just pull that in, and we'll type, before we select, we want to type in, while our value is highlighted in blue, wall, enter, and there you have it. We'll just need to go to Finish Sketch, and we'll want to extrude this guy down into the box, subtracting it, just the height. There we go. So we have our floor left over in the very bottom there. Go ahead and hit OK, and there we have it. If we want to take this a step further, we can add any sort of taper to our walls if you have a core that has tapered walls. So what I like to do, you can either add it into a parameter table or not, is use this draft command and some simple math rather than using a degree over here. We can use atan, parenthesis, and depending on what your taper angle is or how much it tapers over the course of your height, you'll want to customly add this in based on the core that you're using. But I'm going to use a generic number, and I'm going to use 1/4 inch for every foot. So for every vertical foot, this thing tapers 1/4 inch. So 0.25 divided by 1, close parenthesis. And we'll need to choose our walls. So if I want to keep my ID, which is 60 inches, true at the very top of the core here, I want to select, for all intents and purposes, I'm going to refer to this as the bottom of the vault from now on to avoid any confusion. So we'll want to click this. And now it's going to ask for any of the walls that we want to do the tapering. So what we're going to basically do is go around either counterclockwise or clockwise. And our selection, this is where it becomes important, where you select on this actual square. So even though we want to actually select this wall, it's important to note that if we select the top of it up here, it's going to want to use this edge as the rotation point, or it's hinged. So if we select down here, notice how it goes outwardly, and I just realized that I need to change this to 4, feet. I'm sorry, 12 inches. There we go. Makes more sense. Hit apply. Oh, don't hit apply yet. We'll want to select the rest of our walls. So counterclockwise or clockwise around the box, it doesn't matter. Let's go ahead and click our walls closest to the bottom of our floor. And we get this nice little preview indicating in fact that we are tapering from the bottom out to the top. We can hit apply and hit cancel to close the face draft operation. Come into your rules tab, run your set concrete volume rule, go into the parameter tab, and let's just double check that there's a value now entered in there, which indicates that the rule was working and our bill of materials will be accurate.